Hello everyone, author and illustrator Ryan Peters. Please excuse the background noise. My downstairs neighbors are partying it up this lovely Saturday night. So I'm doing a video right now to show the e-bike that I made. It's a super simple setup, anyone can do. I'll explain what I used, the process that I went through to put this sucker together. It's super fast, super simple, anyone can do it, and most of it was salvaged. The only thing I bought was a battery, and all things considered, it was a pretty cheap battery. So this is my bike. It's a pretty nice mountain bike. It's very light, very easy to pedal. It's less than half a year old. It's in great shape. But I saw a bunch of these videos on YouTube, so I thought I'd try one myself. Since I've done several of these, but so far this is the best one I've come up with. So here's what we've got going on here. So as you can see, where are we? There we are. Here's my battery. Obviously, black is negative, red is positive. These are my battery terminals. So the positive line runs, it's these two cables here on the top, these two brown cables. What I used for this was one of those 3-outlet extension cords. They don't have voltage regulators, so I don't like using them around the house anyway. Or, I mean, they don't have circuit breakers, so I don't like using them around the house anyway. But on the topic of voltage regulators and capacitors, this bike does not have any for this. I skipped all of that. This is just the voltage maintained by the battery, so it is important to get a battery that isn't trash for this. So anyway, these two wires on the top here, let me see if I can get y'all a good angle on that. These two wires on the top here are both positives. One of these runs to my throttle, and then one of these runs from the throttle to my motor. Now, I want to point out that this only works with DC motors, not AC motors. It's direct current and alternating current. Alternating current motors are what you would find in corded power tools or anything that plugs into an outlet. That will not work with a battery like this, because this is direct current. If you try to hook up a DC power supply to an AC motor, you will likely blow up your battery or set it on fire, or heaven forbid anything worse than that. So DC to DC, direct current to direct current. If you want to do a DC power supply to an AC motor, it is doable, but all kinds of you would need to build a transformer. You would need to build voltage converters and all kinds of crazy stuff to basically convert the voltage coming out of this to something higher and dumb this down to something weaker at the same time. It's a mess. So DC, and a DC motor is interesting because it doesn't have a positive and negative side. If you hook these up one way, it'll spin one way, and if you switch the wires, it'll just spin it the other direction. So figure out how you want to set this up, how you want the wheel to spin, and then from there you decide how you want to hook up your positive and negative wires to make sure that it's spinning the direction you want it to spin. So the ground wire is super simple. It goes straight from the battery to the motor. The positive wire is super simple. It goes straight from the battery to the throttle, then from the throttle to the motor. The reason that I also feel comfortable doing this project without any sort of voltage regulation or a capacitor of any kind is because this battery is, it does also have like a phone charger and stuff like that up here. If you look under this cover, let's see if I can pop this sucker off of there. If you look under that cover there, where that green light is, there's a USB charger and then a charger port to charge the battery as well. So inside of this battery, there is a minor voltage regulation system. Now, obviously, I wouldn't want to hook this up to something too crazy, because then it would still damage the battery, which could be extremely dangerous. So what I used for this is a Power Wheels motor. I've used a bunch of different ones. This one is actually out of a chainsaw. This was a drive motor that I had also made for this. Again, it's another DC one. It worked fantastic. I will eventually incorporate it into this bike. But for now, we're using the Power Wheels one because, believe it or not, a Power Wheels motor has a higher torque rating than most smaller chainsaws. This was just a climber. It wasn't anything big. It was just a one-hand climber. But this Power Wheels motor, this one single motor, is responsible for moving both back wheels in a Power Wheels vehicle, and this one came out of a two-seater. So it's got some kick to it. It's not insanely fast, but speed wasn't the objective. The objective was to find a DC motor that could handle, well, moving me. So hooking this up is really simple. If you look at the battery here, see if I can get some light on this. Hold on. That should be a little bit better. So, if you look at the battery here, you'll see there's a negative, there's a test terminal, there's your positive terminal. We don't need to worry about the test terminal. There's no capacitor, there's no battery safety mechanism outside of the battery. We're just focusing on the negative and the positive. So I capped these wires off so that they would fit into the terminals nice and snug, because you don't want them bouncing around and one of them falling out. Heaven forbid your ground wire falls out while you're driving this thing. Yeah, not good. Very not fun trip to the hospital. So always ground wire first. Ground your power supply. Then you're positive. Don't touch both terminals at the same time. Tends to not work out too well. Anyone who knows anything about auto mechanics knows connecting and disconnecting the battery is your, biggest hurdle in any of this. Safety is always first. So here's what we got. I'll lift this up off the carpet for you so you can see it in action.